All right, so we're going to continue to develop our notions of trig ratios here. And notice we found three more of them, right? So we have our original three sine, cosine, and tangent from the first page, the more familiar ones, right? And then we also have what are called reciprocal ratios. And they're called reciprocals because they're just the opposite of the ones we already know. So it's not that much more that we need to memorize. And I think, in fact, the easiest way to memorize them is just remember which ones go together. So we have sine, cosine, tangent that are our SOHCAHTOA ones, and then secant of an angle is 1 over, this is why we call them reciprocals, cosine of the angle. Cosecant, well, is 1 over sine of the angle. And cotangent is 1 over tangent of the angle. And if you're wondering why sine and cosine seem to be flipped, it would be easier to remember, right, if cosecant was the opposite of cosine. It's because these come from Greek and these have particular meanings in the Greek language, I guess. So you'll eventually have these memorized just by using them. The reason they exist is just sometimes it's more convenient to write sort of the flipped version of one of these depending on what you're trying to find. Okay, so let's look at an example of solving a triangle. So we are given in this particular example cosine of A, and it has to find cotangent of A and sine of A. So the first move here always is going to be to draw a triangle and label angle A. I could put it up on top here, it doesn't matter as long as I'm consistent. And then let's figure out what we know. So cosine is adjacent over hypotenuse, SOHCAHTOA, right? So that means my adjacent side next to A is 3, and my hypotenuse is the square root of 58, right? Or it could be 6 down here and 2 times the square root of 58, right? We don't actually know if these are the exact values, but we can assume that they exist in this ratio, right? And then looking at what we're finding, cotangent of A is reciprocal of tangent, so that means it's adjacent over opposite. And then sine, of course, is opposite over hypotenuse. So notice we definitely need to find this opposite side here. And to do so, we can use something that you've known probably for, I don't know, years at this point about right triangles, and that's good old Pythagorean theorem, right? A squared plus b squared equals c squared. And we can we'll call that side b. And we can just plug things in, right? So 3 squared plus b squared equals square root of 58 squared. Now, a common error here, I see kids all the time square 58. You do not need to do that, right? Because that just cancels out the square root. Those are opposites, inverse functions, right? So just 58 is left over. We get 9, of course. And then this is a nice one. Okay, so there's 7. And that means we can solve our two other ratios based on that information. So adjacent over opposite, well, that would be 3 over 7 for cotangent. Easy enough because adjacent, opposite, and then hypotenuse, right? And then opposite over hypotenuse, well, that's going to be 7 over the square root of 58. And then I want to do what is called rationalizing the denominator. So I'm going to multiply by what is a fancy form of 1, because we don't like the square root to be in the denominator. Even though they gave it to us that way up here, you'll get this wrong in delta math if you type it in this way. Just like if it asks you to simplify and you put 2 over 4 instead of 1 over 2, it's just not as nice of a way to write your answer. So what I'm going to do is multiply by the root over itself. So I would make yourself a note that what I'm multiplying by is just, it's a weird 1, right? It's anything over itself is 1, so I'm not changing the value of this fraction. But what I get, though, is this. So 7 times the square root of 58 on top, and then the square root of 58 squared times itself right on the bottom is 58. So this is what I would want to say if I want to rationalize denominator. Notice, right, I could, if I really wanted to, go back and find all 6 of these now. Because once you have the 3 sides of the triangle is solved. It's trivial, right? So I now know everything I could possibly need to know about this triangle, other than the angle, which I could go back and solve for both, actually. Right? So once you're given one of these ratios, you can find any other.